Hello, I'm Reza Rad from Radacat. In this video, I'm going to talk about some of the best practices, 23 best practices actually, for developing Power BI solutions, not about sharing or deploying or publishing the solution, but all about developing a good Power BI model. These are best practices that would be helpful for Power BI developers as well as architects, consultants, anyone who is designing a Power BI solutions. So let's check them out. So these tips that I'm explaining to you, they are not in a very particular order, let's say. These are just some of the tips based on my experience developing a lot of different Power BI solutions or helping others to build Power BI solutions. The first thing is whenever you want to reuse some of the tables in your model, and that happens quite often. Let's say you have a date table, you have a product table, you want to reuse it in this Power BI file or even in other Power BI files. As long as it is in the same Power BI file, you just reuse it. You created that table in Power Query. But let's say if you want to use it in another Power BI file, copying the Power Query transformation or the M code, pasting in another file will create the challenge of maintaining that code again in two different places, not having a single version of truth for your source code. One solution for that would be doing that or building that table using Power Query in Dataflow, which is Power Query Online, which runs in Power BI or Power Platform Engine. It runs the data transformation using Power Query. It stores it in Azure Data Lake Storage or Dataverse, and then from as many as Power BI files you want, you can get data from it. Then whenever you want to change the data transformation in that shared dimension or table, you just go and change it in the data flow. The second tip I want to explain is similar situation but with DAX calculation. Let's say you spend a lot of time creating a DAX calculation. That might be year-to-date calculation, year-over-year calculation, any of the time intelligence calculation or percentage of a total for particular situation. You spend time to create it. Now you want to use it in multiple reports. The same situation also happens when you have multiple report developers for your Power BI model. You have John and Jack. They both want to build visualizations on your report instead of sharing the PBIX file with them so that they go and build their own reports. So that then you have different versions of the PBIX file, and whenever you want to change it, you want to kind of like merge those changes, which is not easily possible. What is better to do is to create a shared dataset. A shared dataset is basically a Power BI dataset that has been used in multiple Power BI reports. So those reports would be more like a thin report connected to the shared dataset and visualizing the data from that. You can have multiple report visualizers using the same data set, and they can also define some measures called report level measures, or they can even create a data set on top of that data set called chain data set. The third tip is when you want to use Power Query functions. In Power BI, you can create reusable steps in Power Query. We call it Power Query custom function. Let's say you have sales data of all different branches. They all similar, but they come in different Excel files, or they come in different servers, different SQL Server instances of servers. So you have a set of processes that process this data and load it, and now you want to do that for all of those sources. So instead of repeating your code, you can create a Power Query function and reuse it in multiple places. For each of these tips that I'm explaining to you, there's a link down in the description below, which gets you to my blog article and explain all of these in details with demos. So this post or this video is not really about explaining each of these in details, just giving you the tips, and then you can use those links to go and learn more about those in details. The next one is parameterize data sources. Instead of using the database name, the server name, the file path, a lot of these things directly as a hard-coded value in your Power Query or Power BI desktop, try to use parameters, because if that value changes, for example, if you want to change it from production server to test server, if you want to change it from this folder path to another folder path, If you don't have parameters, then you have to open the Power BI desktop, Power BI file in Power BI desktop, change data source settings. Sometimes you even need to go to Power Query editor and change something in there. If you use parameters, you can change parameters even from Power BI desktop main window. You don't need to go to Power Query editor. Or if you have your file published to the Power BI website, you can even change parameter values in there and then refresh your Power BI dataset. If you have too many tables, and that's quite often happening, try to create folders in Power Query. We don't call them folders, we call them groups. Basically, group is a folder. So in Power Query, you can create groups or folders that you can have these queries under that. The way that you define these groups or folders, it's really up to you. Some people define a folder per data source, like all the tables coming from SQL Server goes under this folder. All the tables coming from Excel or this shared folder goes in there. Some people define it based on the entity they are working with, like all product related tables goes under that. Some people define table folders based on how these tables are treated. Like some of them are table tables, some of them are final queries, which we loaded into the Power BI. So defining these folders can be helpful in your solution. Disable or enable load is an important settings to set. By default, all tables in Power Query are enable load. That means that table will be loaded into Power BI. Most of the time you want to do that, but there are certain scenarios when you use the table just temporarily. Let's say you have a product category table, product subcategory table, and product detail table, and then you combine them all together in one product table. You merge them together in one product table. Then you have everything in product table. You cannot delete these three other tables because they are used in building product table. But if you load them into Power BI, you have 3 extra details that is impacting your performance, because the more tables you have, the more data consumption you get. And also it makes your model confusing. It creates extra relationships when it's not needed. You can disable the load of those unnecessary tables, which happens a lot after combining tables together, merge, append, or other methods of combine. The next tip is don't load the entire data into Power BI, just load whatever is needed. For example, you might have a database with 200 tables, but you just need 3 tables. So just bring those tables, don't bring all others. In each table, like let's say you have a table with 150 columns, you don't really need all of that. Perhaps in your reporting, based on your requirement, you might need just 5 columns. So just import that. You can later on go and add more columns if you want to. And it is also about the data in the table. Let's say you have a table with 20 years of sales transactions, but you just want to analyze the last 3 years of data. So just import that last 3 years of data. In Power Query, you can filter the data, or in the SQL statement that you are getting data from the source. In any methods that you are getting the data from the source, filter the data based on anything that you require, and just bring the data that you need. That would save a lot of space in Power BI. Saving space, saving memory would mean better performance, of course. There are 2 different ways of copying a table in Power BI, reference and duplicate. Make sure you use the right option when you are creating a copy of a table. Duplicate creates a copy of a table with all the existing steps, an identical copy of that where you can keep them totally separate and apply some changes here, some changes in there. Reference is using the main query as the reference point for the second query. The second query would be looking at the first query, but then can have more additional transformations on that. Make sure you use the right option. Always try to design a multi-layer architecture in your solution. This multi-layer architecture can be about data flows, data sets, and thin reports, like having Power BI data flows, having even data marts, data sets, shared data set, and thin reports on top of it. Or it can be anywhere else as well. Inside data flow, you might design a multi-layer data flow, like a staging data flow, transformation data flow, another transformation data flow, layer of transformation. These layers would help in case that you want to make any changes. You just need to change one layer. For example, if your data source structure changed, you just change the staging data flows. The data set can be also itself a multi-layer architecture. You can have data sets, then chain data sets from those data sets. This multi-layer architecture, anywhere that you want to reuse components, can be really helpful. So make sure to use that. Some visualization tips. You can have slicers in different pages, but if you are using one slicer across multiple pages, try to sync them together so that when you change a value on one page, it also changes in other pages as well. One common practice, if you have too many slicers, is to put them all in one page, call it slicer page, and then from all other pages, first sync this with all other pages, then from all other pages have links or buttons, bookmarks to bring it into here, make changes, go back to that page and see the impact of that. That is really common practice in many Power BI solutions. Again, on the visualization side, try to use a theme file. In your organization, you might have some color codes, such as, let's say, these are the three main colors we are using. This is the contrast of colors we are using. Now, you can go to every visual and use those colors, but the better way is to define a theme file. And in Power BI Desktop, you can easily create your own theme file, choose the colors that you want. Theme file is not just about the colors, it is also the font sizes, generic specification for each visual, such as the border, the shade of the colors you want. Those elements you can use that, change that. Once you created the theme file, you just need to apply it. And make sure that you save that theme file in a shared folder, especially if you are part of a Power BI team. That way, other team members can also use it instead of creating their own theme file. So everyone would have a consistent view of the reporting. Background image for report pages. This is also an extension of the theme file where you can create a background image with header, logos, footer, whatever you want to put in there, the background color. You might define sections. This is the sections that I would put my slicers on. This is the sections that I would put my charts on. And create few of these background images for different types of report pages, and then reuse it across your report so that when users navigate between different report pages, they don't get suddenly surprised by totally different view of the report. It all looks a smooth flow of the reporting and visualizations. Conditional formatting is a really important process in visualization. When you visualize something, you are trying to convey the right message to your users. And part of that can be by conditional formatting, color coding, making your big numbers look different, your small numbers look different. Conditional formatting can be applied hard-coded inside each visual, or you can even use DAGs, parameter tables, disconnected tables, what if parameters, all of these methods to create that. I would suggest using DAGs and parameter tables for that, because when you use it, then you can reuse it in multiple places. Again, I explained that in another video, so go and check it out. Especially if you have those colors in a table, you can easily go and maintain that in the future, change it. The next Power BI refresh would pick those new colors instead of going and changing all of those hard-coded values in the Power BI file. So conditional formatting can be more dynamic, easier to maintain when you use DAGs and what if parameters and tables. Measure tables. When you have a lot of measures, sometimes it might be hard to find where they are, and you might need to scan the tables to find where they are if you don't remember exactly what is the measure name. Having them all under one measure table is helpful. A measure table is basically a blank table. It doesn't have anything. You can create it in any ways, and then add all the measures under that. You can even use display folders, which is just like virtual folders under that measure table, to categorize your measures. These are modeling tips now. Try to use hierarchies. In Power BI, you can create hierarchies such as category, subcategory, and the product itself, so that you can have a consistent view of different levels of hierarchy. Without hierarchy, you can still do that. You can drag and drop these three fields into each visual, but it wouldn't be consistent. It would be more job for you to do. Every time you want to use it, you have to drag these three fields, but with hierarchy, you just drag and drop the hierarchy over there. You would have a more consistent view with that. Power BI sets automatically the aggregation on the field level depending on the field data type. Like if it is a numeric data type, if it has not been used in a relationship, if it's not in a dimension, then very likely Power BI would mark it as auto summarizable. Like a year column or an age column in a disconnected table is very likely to be auto summarizable, and you don't want that. So you can go and change that at the field level so that everywhere in the visual you go, then you can see the right summarization for that. Power BI comes with its own default date table, but the default date table is good for only like simple situation, creating proof of concept and things like that. If you want to use that in a complex situation, let's say weekday versus weekend data analysis, what about public holiday analysis, custom calendar table, things like that, then it is better to create your own date table. The date table can be created using Power Query, using DAX, using SQL query in the data source. It doesn't matter how you create it, but if you are creating it using Power Query, then it can be generated in data flow so that you can reuse it in different Power BI files. And when you create your own custom date table, make sure that you mark it as a date table so that Power BI will use that for time intelligence calculations, and also uncheck the auto date time in Power BI options so that it doesn't create the default date table anymore. Power BI reports are mobile friendly by default, but you can have a better view of the mobile reports when you go and enhance it. This design is part of the report layout design. You can have a desktop design and mobile friendly design. You can have different font style, some visual characteristics for mobile versus the desktop. This is really important in adopting the Power BI solution across your organizations, because probably your users, those who are in board of directors meeting, they won't have access to a computer every time, but they have access to their mobile devices, so they can see those reports easily in there. Some consideration for big tables. If you have a table with too many rows, then consider using aggregations. Aggregation is a grouped by version of a table, but certain number of fields that can be smaller of the original table, because if the original table, let's say, is 2 billion records, the aggregated table of that by date might be only 7,000 records. By date and by customer might be only 100,000 records, which is much smaller than that original table. These aggregated tables normally are imported in Power BI model, so they are fast to respond. Power BI first try to resolve the visualization query by these aggregated tables. If it cannot, then it goes to the original table. So aggregated tables make things faster. And you can define layers of aggregation, like try this smaller aggregated table. If it doesn't work, go to the next. If it doesn't work, go to the next, right? Power BI also enables you to have automatic aggregation enabled. It's part of Power BI Premium functionality. So definitely consider aggregations. It's a really important step when you have large data and when the performance is not working good because of that size of the data. In addition to aggregation, another thing you can do on tables with too many rows is incremental refresh. Incremental refresh means that you don't load the entire data every time in Power BI. Let's say if you have a table with 20 years of data and it is over, let's say, billions of rows, why do you need to reload the data of 20 years ago or 19 years ago or 18 years ago? You probably need to reload the data of the last year, but not all those historical information. So you can probably populate the historical information once, that last 10 years, 20 years, and then the most current year, you just reload that again and again. This is incremental refresh, can be set up really simply, and it will be really helpful. It will make your refresh time much faster in a Power BI dataset. In addition to that is hybrid tables, where you can put the most recent period of your table as a direct query, where you get the data freshness for the most recent period. You don't really import that data into Power BI, you keep it in the source, so every time you query that from the source in case you want really fresh data for your latest period of the data. most recent period of the data. On the modeling side, try to design star schema models. A star schema model is where you have fact tables, including all your measures, aggregate table, numeric fields, and dimensions, including all the descriptive information. Dimensions are slicing and dicing fact tables, so there's a one-to-many relationship from dimension table to the fact table. You can have multiple fact tables in your star schema. Each of those have direct relationship with their own dimensions. This is usually the best design of the Power BI model, so let's try to stay on that. Sometimes when you are designing relationships in Power BI, you get to the situation that you feel that you need to create a both directional relationship. You can avoid that by different methods. First, a fully star schema design, a proper star schema design doesn't come with that many requirements for both directional relationship. If it comes, there are certain ways that you can work around on it. You can think of different approaches to do that, probably get the values from a table that is getting filtered. Worst case, if nothing would work, you can use cross filter inside a DAX measure instead of making that relationship really both directional. That way, only when you use the measure, you get the performance impact, not everywhere. Finally, it's good to go through your model over time, do some cleanup, remove some of the fields, columns, measures that are not necessary anymore. And there are many community tools that can help you with that. There are tons of different tools and they are all great. The one that I use myself is the Power BI Helper because I'm more used to using it. But there are many other tools as well, which you can easily go and see what is used, what is not used in your model and clean it up. So these are some of the tips that I wanted to share with you. I will share some best practices in deployment, publishing, and sharing later on. These are best practices for development. Let me know what your thought is on these, and until the next video, have fun. Bye.